Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, we are going to have another fresh and interesting new topic, that is cycle geometry. In this very first lesson in this main topic, cycle geometry, we are going to discuss the theorem number 1 in this cycle geometry. So let's begin. After completing the very lesson today, my dear student, will be able to find the measure of the angle, that is the size of the angle at the center of a cycle. You also be able to find the measure of the angle at the remaining circumference. This is what I hope you'll be able to do after completing the very lesson today. As usual, my dear student, in your favorite segment of the lesson, that is Maths is Fun. Today, I'm happy to give you another interesting number. This number is 23. 23 is another interesting, another amazing number. I will explain what is interesting about this number 23 after completing my lesson today, so don't go away. My dear student, in this main topic, that is cycle geometry, you should be dealing with the theorems. It is those theorems that we learn and we use them as a tools in order to solve the problems in this cycle geometry. So we are starting with the very first theorem, that is theorem 1. And theorem 1 simply says the angle at the center of a cycle is twice the angle at the remaining circumference. Let me just use these two drawings in order to explain this very theorem. So the theorem says if you have an arc, for example, like this very one, look at it. This arc, you can see it in red. This arc now subtend or formed this angle at the center of the cycle, and that angle is colored blue, and it is now letter X. And that same arc also subtend another angle at the remaining circumference. So if you are considering this very arc that I colored the red, this will now be the remaining circumference. This will now be the remaining circumference. So if that same arc, after subtending an angle at the center, also subtend another angle at the remaining circumference, you can see the angle here colored red, and it is now lettered Y in the very first drawing. So according to this very theorem, this X will now be equals to 2 multiplied by Y. If I go to this drawing also, if you look at this arc that I colored red, that is the major arc, then the remaining will now be here, the remaining circumference. So this arc now subtend an angle alpha, the center of the cycle, and it is now colored blue. And the same arc subtend another angle beta colored red in the other or in the remaining circumference. So according to these very theorems, both in these two drawings, the angle at the center will now be twice, meaning 2 times the angle at the circumference. That is, if I consider this very drawing, the very first one, this X will now be equals to 2 multiplied by Y. That is, the size of the angle X will now be double the size of the angle Y. Similarly, in the second drawing, the angle alpha, that is the angle at the center, look at it, the angle subtended by this major arc. That angle alpha, its size will now be 2 multiplied by the size of the angle beta. And in each case, the reason is now the shorter form of this very theorem, which says angle at the center twice angle at the remaining circumference. So this is the very first theorem that we learn in this very topic, and it is very, very vital. We make use of this so often in solving problems in the cycle geometry. Let us just move and take examples. Example number 1, it says in the figure below, O is the center. Look at O. This is a cycle. The center of that very cycle is at O. O is the center of the cycle. The question asked is to work out the size of the marked angle. The marked angle here is this angle lettered A. Solution to this very problem. So we make use of the theorem we have just learned in order to find the size of this angle A. It is this arc that subtend angle 118 at the center of the cycle. And in the same arc also subtend angle A at the remaining circumference. To find A, what I'm simply do, I will make use of the theorem that I have just learned, which says the angle at the center is twice the angle at the remaining circumference, which means to find this A, you now just take the half of 118. And this is exactly what I have done here. So A will now be equals to 118 divided by 2. And my reason is always angle at the center equals to 2 times the angle at the remaining circumference here. So division of 118 by 2 give a result of 59 degrees. So the size of this angle A, that is the marked angle, is now 59 degrees. Let us just move and take another example. Example number 2. In this figure below, O is the center of the cycle, and you are asked now to work out the size of the marked angles. Here I have angle K and angle G as the marked angles. So you need to find them all. Solution to this very problem. So remember the theorem that you have just learned, which says angle at the center is twice the angle at the remaining circumference. If I can see this theorem here applicable in this very question, I can find the G, for example. G you can see is the angle at O. O is the center of the cycle. So G is now angle at the center. And this angle G is subtended by this arc. Look at the arc colored red. Look at the arc colored red that formed the angle at the center, angle G. And that same arc also subtended another angle at the remaining circumference. This angle 47 degrees. Look at it. Based on the theorem that you have just learned, it says angle at the center, that is this angle G, would now be twice, that is double the angle at the remaining circumference, that is this 47, which means the angle G will now be equals to 2 multiplied by the angle 47. 47 is the angle at the remaining circumference. And my reason is now angle at the center equals to 2 multiplied by the angle at the remaining circumference. Always you must write the reason in the bracket. So multiplication of 2 by 47 gives you answer 94 degrees, which means that the size of this angle G is now 94 degrees. So what remains is the angle K, because the question says we are to work out all the marked angles. I have angle G and angle K here. So let me find the angle K. To find angle K, you look at this very triangle. Look at the triangle. Look at it. I'm just tracing it out. From O to circumference, each is now radius. So this triangle will now be an isosceles triangle. Look at it. It's now going to be an isosceles triangle. This K is a base angle. So if this is K, this is also going to be K. These are the two base angles. So to find the size of just one of the base angle, what you simply do, you now subtract the third angle from 180 and divide the result by 2. That is why I remove the size of the angle G, which I have here as 94. Whatever result I have will now be the sum of the two other angles. And as those two other angles are equal, so I'll divide the result by 2 to get the size of just one base angle, which is my K. So substituting what I have as my J, I will now have 180 minus 94. J is 94, which we just obtained. So subtracting the 94 from 180 and dividing the result by 2 will give you result 43 degrees. That will now be the size of the angle K. Let me just move and take one more example. Example number 3 says in the figure below, O is the center of the cycle. The question asked here is to work out the size of the lettered angle. The lettered angle in this case is this angle W. Solution to this very problem. Looking at angle W and angle this 115 degrees, and try to connect them using just the theorem that we have just learned. This 115 is an angle subtended by this major arc. Look at it. Look at the major arc. I colored it red. It is this arc that subtend 115 at the remaining circumference. And it is this major arc that subtended this blue angle at the center. Let me just call it X. If I call this angle, this reflects angle X, meaning the angle at the center subtended by this arc, the major arc. I call it X. According to this theorem that we have just learned, the size of X will now be double the size of 115. So there my X is now going to be 2 multiplied by 115. And the reason is it is angle at the center, the angle X, equals to 2 times the angle at the remaining circumference. And the angle at the remaining circumference is this angle 115. So multiplying 2 by 115 correctly, you now have 230 degrees. So you now make use of this x to find the w, because the two angles w and x are simply angle at a point. So addition of two angles at a point gives you 360, which means to find the angle w, what you need to do is simply subtract the angle x, which is 230, from 360. So w will now be 360 minus 230 degrees, and your reason is angle at a point. So subtracting of 230 from 360 correctly gives you result 130. So this angle marked W, the size is now going to be 130 degrees. With these few examples, I have come to the end of this very lesson today, my dear student. Let us just move quickly to the next segment, that is the self-evaluation segment of the lesson. My dear student, this is your self-evaluation segment of the lesson. In this segment, you have the opportunity to measure how well you understood this very lesson today. In this segment today, you have just two questions to answer, and those two questions are based on what you have just learned in this very lesson, that is cycle geometry theorem 1. Each of the two questions will now be displayed for just 1 minute on your screen. After 1 minute, the solution to that very question will now be displayed, and that solution will now be on your screen for just 30 seconds. But you can have full control of the timing by just pausing the video. When you are done, you can now play the video to resume again. So if you are ready, take your biro and paper and start the test. So my dear student, this is the end of this very lesson. Let me just explain what is interesting thing about this number 23. 23 is a prime number. And among the prime numbers, it says, is the smallest among those prime numbers that what happen, that has numbers that are consecutive as it is digits in that prime number. If you look at 23, it has digit 2 and 3, and 2 and 3 are consecutive, meaning after 2, the next integer or the next number in the sequence of integers, it is now going to be 3. So among the prime numbers, it is 23 that is the smallest that have digits which are consecutive. If you move in the sequence of prime numbers, you still have another number which is prime and its digits are consecutive, but this 23 is the smallest. Another interesting thing about 23 is says if you add the first 23 prime numbers, this is what you are going to have, 874. And this very sum is exactly divisible by 23. So this is amazing. We see more of these things in mathematics in our subsequent lessons. Thank you for your attention.